Why was this print circuit board thoroughly cleaned after soldering at the factory, while this one was not? It all comes down to the customer's requirement and to certain processes that come later, especially coating and encapsulation processes that require a clean PCB surface. When you send your 100 PCBs to an assembly manufacturer for soldering, you specify whether you want them cleaned or not. If you are not sure, a good manufacturer will ask you a few questions. Are you going to apply a conformal coating to the PCBs later? Or maybe you want to completely encapsulate the PCBs inside their enclosures using a potting compound. Maybe your PCB carries critical signals where even small leakage currents could cause serious problems. Maybe it's simply important to you that the PCB is completely clean and free of flux residue. Or is it just a DIY device that doesn't require cleaning? These questions are not random. First, if you are going to apply a conformal coating or encapsulant after soldering, the PCBs must be thoroughly cleaned. A clean surface provides proper wetting and maximum adhesion between the protective coating and the PCB. If you apply the coating over flux residue, that residue will remain between the PCB surface and the protective material. This can reduce adhesion and ultimately reduce the reliability of the protection. Second, cleanliness is also extremely important for PCBs with high impedance circuits, very small measurement currents, high voltages, very small spacing between conductors, and high frequency circuits where parasitic parameters become significant. A residual film of flux can create paths for tiny leakage currents, which can affect signal integrity and overall operation of the PCB. Third, PCBs used in medical equipment, aviation, railways, automotive applications, and other critical industries are always cleaned. People's lives depend on their reliability, so the requirements for the cleaning processes are extremely strict. Fourth, maybe you simply want your PCBs to arrive completely clean and you are willing to pay for it. In many cases, customers choose not to clean inexpensive PCBs simply to save money on manufacturing. Most cheap electronic PCBs are not clean for exactly this reason. Everything I have just described applies to all flux and solder paste classes used for PCB assembly, including most usable, no clean roll 0, rail 0, and oral 0. But what should you do if you are soldering at home, even if you are assembling small batches of PCBs? In this case, the risk of using poor quality materials becomes much higher. When people doing hand soldering at home, they usually try to buy cheaper fluxes and solder pastes from online marketplaces. And those marketplaces are full of low quality materials from China, sold at very reasonable prices. That's exactly where the problem begins. Nobody can reliably tell you what flux classifications is actually used in the flux or solder paste you have chosen. Very often there is no classifications on the container at all. All you see on the container is a misleading no clean label, but inside you may actually have a very aggressive acidic formulation. Flux residues trapped under components can soon cause green corrosion and current leakage, potentially even leading to a short circuit. That's why for home soldering, PCB cleaning is mandatory, and it's better to clean the board several times. On my YouTube channel, you can find playlists about cleaning PCBs. The flux classification should be specified on the packaging or in the datasheet of any flux or solder paste. I will leave a link in the description to my video about flux classifications. You will also find a link to Diamond Flux products in the description if you don't want to worry about poor quality fluxes while soldering. Subscribe to my YouTube channel and to my Patreon. Like this video and let me know in the comments what you think. Bye bye.